Good morning. My name is Skander, Hannachi, and myself, along with my teammate Rajesh, we are part of the Applied AI Engineering team, Google Cloud, and today we're going to talk to you about Vertex AI, the Gemini model selection, prompt design, and prompting strategies. Now, I'm going to preface this for anybody in the room with a background in econometrics or statistics. We're not using the word model selection in the strict statistical term of like using the AIC or the BIC to select a model. No, we're using model selection in the colloquial term here. So first part of our presentation, we're going to kind of preface it with like how you should think about choosing the right Gemini model for a production, a business product or business solution use case. Then Rajesh is going to talk to you about prompting strategies, how to properly prompt Gemini models. And then finally, we're going to kind of zoom out a little bit and look at how the topic of prompt engineering itself needs to be grounded in linguistics best practices, not just in like hacking into LLMs. Okay, so first we're going to talk about Gemini model selection. The starting point for this kind of like how to select the right Gemini model is that right now, large language models are a net new research topic. They are a very new capability. The field is evolving very quickly. And so we don't have a lot of practitioner-based best practices. And most practitioners are taking their cues from researchers. But the researcher mindset is very different. Researchers, because they are trying to achieve scientific progress, tend to think in absolutes and according to abstract criteria when they evaluate models and when they come up with ideas for new models and new capabilities. And that's a good thing from the perspective of technological and scientific progress. It's obviously a good thing. But from the perspective of practitioners, it can be sometimes counterproductive. When you're thinking about a product, when you're thinking about like an audience acquisition challenge or a sales uplift challenge, or when you're thinking about like a product cataloging challenge, all these things, rouge and blue metrics don't really matter that much for your business. Whether your model performs well on Big Bench or on MMOU or something like that doesn't really matter from a business perspective. So the kind of like abstract absolute thinking that researchers apply when they are evaluating their models, and the notion that like singular focus on that one model to solve all problems isn't very useful when you're trying to solve business and product problems. Instead, you want to think that there are multiple models, different models for each use case. Sometimes you don't need a model at all. And you also want to make sure that you are evaluating your models based on your business and product requirements, the functional requirements of your solution, not on abstract academic criteria. So from that perspective, here's how you should be considering like when to use Gemini models. So at a high level, we have, are you going to use Gemini to improve or optimize an existing solution? Or are you going to use Gemini to completely transform a solution? So what do I mean by that? We have, for example, like one of the solutions our team built, myself and Raj and other teammates, was a product cataloging solution. We built that solution using Palm. Then later when Gemini was released, it turned out that Gemini provides more accurate results. So here, that's a case of the Gemini model optimizing or improving upon an existing solution. So you're taking an existing pipeline, and now you're kind of replacing whatever incumbent LLM you had with the Gemini LLM, and that improves the performance. Now, there's a more interesting way of looking at this, there are some scenarios where Gemini's multimodal capabilities, Gemini Pro 1.5's 1 million token long context, actually allow you to fully transform, to completely rethink how you are approaching the solution from the start. So for example, we have a lot of customers who are now feeding video directly into Gemini and summarizing the video directly, and that is providing a lot of use cases. We have some customers who are overcoming the limitations of RAG, and this is not to say that RAG is obsolete. No, RAG is still very, very relevant. But in some scenarios, you can overcome the limitations of RAG by instead leveraging the long context of Pro 1.5. So those are scenarios where you're using Gemini to completely transform your solution versus just optimize it. So here we have a decision tree which essentially allows you to think about which of the Gemini and Palm family of models should you pick based on purely functional criteria, so product thinking, but not just purely functional criteria, but also based on like empirical benchmarking that our team did with not just on like abstract academic benchmarks, but we were working with Google Cloud customers on real-world data sets for real-world use cases, and we observed that here are the scenarios in which the different flavors of Gemini and sometimes one of the text bison or one of the Imagine models would perform best. So I'm not going to go in detail through the entire decision tree. I'm just going to this is kind of lays out how to think in a functional way about which Gemini models to use and which Gemini models, or sometimes which models from the Palm family to use, and how to align them with the functional criteria of your use case. Now, I'm going to go to what does this mean from a practical implementation perspective? Well, first, using that decision tree to match the right model to the right use case, you are going to have different models for different solutions. Again, we're trying to avoid the one model to rule them all mindset here that's kind of percolated over from academia into the practitioner world, and instead focus on the fact that you can have separate models for each solution. But this is only the beginning. Now, if you look at how some of our more advanced customers and how we think about it ourselves here at Google Cloud, then it gets more interesting. You'd start using a model router. So how does a model router work? A basic model router, you will have business rules. You might have user input, which based on those business rules and user input, you route to one model or the other from the Gemini and Palm family in order to get optimal performance. And you can do so not just to perform optimal performance from a user perspective, but also to reduce cost. So you might get the same performance for a prompt with a higher end model and a smaller model, but when using a model router, you're also effectively bringing in cost efficiencies and latency efficiencies as well. Now, the next most advanced level is now you start collecting data, performance data and user feedback data, and then you actually build a routing model. So now you have a model that's routing that learns which one of the Gemini and Palm models performs best, and then you route the prompts to that model according to the learning. So you're starting to build a continuous feedback loop. So with this, I'm going to hand it over to Rajesh to kind of speak a little bit more about how you start thinking about the prompts themselves.
All right, so last few months, it has been a privilege to work with tens, if not thousands of, hundreds of customers to onboard on Gemini for their use cases. Today, we'll be sharing some of those tips and learnings or making Gemini 1.2 Pro and 1.5 Pro work for your use cases. And we'll keep our talk focused on text use cases. So before we start, key things to remember and also remind ourselves, every LLM is unique with its own strengths and weaknesses. As Skander was saying, there is no one LLM rule all. So what we shared today may have varying levels of effectiveness across different LLMs, even within the versions or the similar iterations of the same model. So get ready to experiment, because prompt techniques should be considered as a basis for exploration, and experimentation and evaluation are essential to determine if the LLM is actually use case with your own context. And as LLMs evolve, they're going to be only more capable and more they're going to be performing well. So these tips are going to be evolving as as these models actually get onboarded as well. But nevertheless, these are going to be a great start for you as you look into these new models. So we'll be emphasizing throughout the talk that the rigorous and systematic testing and evaluation would remain crucial for optimizing an LLM performance. So there is no silver bullet to that. So you have to experiment and then evaluate and then repeat that. So we all know Gemini is a bigger, more capable model than its predecessor Palm. What it means is you don't really need as many instructions as text bison or chat bison did. Well, not so good news is you still need to follow some prompt design guidelines, and that's what we'll be talking today. Before we do, let's actually understand what exactly a prompt is. So for simple tasks, clear and concise instructions works well, but however, for complex prompts, specifically for your enterprise settings, you need your prompts to be carefully structured to ensure the model consistently performs as intended. So this applies to all models irrespective of their size and type. So the table here lists essential components of the prompt highlighted, such as persona and goal that actually tells the model what role it has to play. and what it's good at, and what you want the model to achieve. Then there are optional components that are not highlighted, so that you can add or remove as needed. So for example, the tone or style of the prompt, or the context, few short examples, or the output format, you can just add or remove as depending on your use case. And again, all these are like logical components of a prompt, so you can feed into a system instructions which are supported by Gemini. So here you can see an example prompt for a travel assistant that helps build itineraries based on a particular location. So the prompt clearly tells you the role it has to play, like it's a seasoned travel blogger, which has a knack for finding hidden gems, and goal is to create memorable travel itineraries. So the context here is, it also tells you who its customers are and what they look for, followed by the instructions on how to create those itineraries, and also the tone and format of the itinerary. All right, so now we are familiar what exactly the prompt is, so let's actually look at some of the tips for you to get started. So the tip number 1 is simplify the instructions in your prompt. So as mentioned earlier, you do not need verbose prompts because Gemini follows terse instructions pretty well and closely. So here in the example, you can see the prompt for extracting entities from a transcript, and the output is in the JSON format. And also notice that there are no few short examples given, but even then the Gemini gives you a valid JSON response and does a pretty decent job in extracting those entities. And also notice the temperature is set at 0.1, and we'll actually come back to this in a few slides. So along with tip number 1, Gemini follows terse instructions as long as they are very clear and specific. I know it sounds banal and simple, but this is actually often ignored. So here in the example, you have a very simple instruction called summarizing meeting notes. So which works, LLM is going to respond, but the response is not going to be as, as good as like the modified version here, which basically tells you much clearer, specific, explicit instructions for the LLM. For example, summarize the meeting notes in a single paragraph, write in a markdown list of the speakers and action items that are available. So the response is going to be a lot better. So this is actually one of the real customer example for generating call to actions based on a product description. So left is the original prompt and right is the modified prompt. So you can see that the response from original prompt is a bit verbose with a bit, for call to action, there is actually much lengthier response. So we modify the prompt by simplifying the instructions and also calling out the constraints from the output very clear. So the response is a lot better and actually fit for a short call to action. So tip number 3 is giving a persona to the LLM based on the use case. So adopting a persona helps the model to steer its responses, which can improve accuracy. So here in the example prompt that we're building with an internal application, which was answering questions based on the public documents, specifically for cloud networking products. So as you can see, when you jump right away asking the question, the quality of the response from the LLM was not really great. So what we did is we had to rewrite the modified prompt, clearly call out the persona that LLM has to pretend. So in this case, we specifically mentioned like Google Cloud Platform Technical Support Engineer who specializes in cloud networking, which responds to customers' question. So this completely changed the tone, the quality, as well as the length of the response. All right, so tip number 4, limit to a short preamble. So having longer verbose preamble with repeated and too many instructions is not going to do any good, and it's going to actually do more harm than any good. So what you see here is an example from a customer who was migrating from TextBison to Gemini. So on the left, you can actually see the TextBison prompt, which is a little bit verbose with step-by-step instructions and how to post-process the response and validate the response as well. Now, the response from the Bison was rated as very high by the human raters during the evaluation process and was actually considered as a ground truth. So we were migrating to Gemini, we migrated the prompt as is, but unfortunately the response was rated pretty low by the same human raters. So in this case, we had to rewrite the prompt following some of the tips, like simplifying the instructions and also keeping the preamble short by removing those redundant or repeated instructions. So after making those changes with a few iterations, we were able to get the same or better quality of response. All right, so tip number 5 is to do with the safety filters. So safety filters are built-in content filtering within Vertex AI that allow you to deploy your application safely and responsibly. So by default, our safety filter threshold are set to a bit higher than what customers are usually used to, and that can actually block prompts or even generate empty responses. So if you're getting into similar scenarios, so there's a way to tune or control safety filters using the SDK or the UI by turning the filters to a threshold that you desire based on the content in your prompts. So it just takes like 3 steps to set and use these safety settings using SDK, but you can also do it using the UI as well. And there's a link to the collab that you can follow later. All right, tip number 6 is experiment with temperature settings. So temperature helps to tune the degree of randomness and control how creative or conservative you want the model to respond to. So the optimal temperature depends on how the model was trained in the specific task and also the what is the desired response style that you want. So it's recommended to set the higher temperature for creative tasks or instruction following and then lower temperature for your code generation or factual task. So definitely do experiment with prompt variations and temperature, and we recommend starting with a temperature of 0.5 with Gemini and then see either up or lower depending on your use case. And there are other prompt settings that can help you to control the output for a given prompt, such as top P and top K, which are there in our prompt engineering guidelines that you can actually refer to. So here is the same example that I saw in the tip number 1, which is for extracting those entities, except the temperature has been adjusted to 0.7. You can see that the output JSON is actually much closer to the expected format with a lot more detail, and which is actually what the customer was intending to find out as well. And again, we are still not using any few short examples. Now, because we are talking about few short examples, the question is how many examples are really good enough? So what we have found is over multiple use cases, using fewer examples with enough variety and diversity actually works better. So quality wins over quantity. So our recommendation is to start with at least 2 or 3 examples and then max it up to 5. So interestingly, for this customer use case, which was involving generating a valid JSON response, 1 example was actually enough to generate a good JSON response. Now, as we added more examples, what we saw is the quality of the JSON response was actually getting lower. All right. So next tip is to limit your negative examples and instructions in the prompts. So again, it's better to say what to do than what not to do. So we have observed quite a few prompts where negative constraints or negative instructions, if there are too many of those, the prompt was not actually responding better. So in this case, you can see there are a lot of those do not do this type of instructions. Now, this can be rewritten positively as you want to get done. So a good example of that is one of the prompts that we had that had only negative examples as few short examples. And there was no surprise that model was always responding that it could not really respond to the user input because it could not find that information, was asking to contact the customer service. Now, we just rewrote that same prompt with simple and clear instructions and removed all the negative examples, and the model responded a lot better. Again, the takeaway here is to limit those negative examples and restrictions and instructions, and we are not suggesting to remove it altogether. All right. So the next one is using separators to clearly identify distinct components of the prompt and demarcate your instruction blocks from the actual data. So this can clearly make a difference when you are referring to specific sections in the prompts or prompts with variable input. So as you can see, the prompt here clearly distinguishes those examples, contexts, and instructions and the user input. So here we show XML tags, but it could be any sort of delimiters that you would like to use, like markdown formatters or anything of that sort, as long as it's actually demarcating these instructions clearly. Now, I mentioned XML tags in the previous example, so that brings to number 10, which is using XML style markup to structure your prompt. Again, you can use this to demarcate your few short examples or prompt components that can help. And we've seen over and over that this is specifically useful when you're working with complex prompts where you have a lot of few short examples or a lot of context that you're getting in for those RAG style workflows. So the example here is from, again, one of the representative example, which is multi-turn question answering chat, which responds to user questions based on transactions or the transaction history, which is present in the prompt context. So here we are using XML tags to demarcate the context and instructions within the XML tags. All right, so let's now look into some specific tips working with Gemini 1.5 Pro, which is our mid-size multimodal model, which with a long context that can support up to 1 million context window. So when you have these long context windows, you typically combine multiple input sources into a single prompt and take advantage of that 1 million context window. So when working with a long context window, it's important to structure your prompts, separating out, again, that input data from the instructions. For example, here, the prompt is prompt that we have from the application that answers customers' question based on a set of documents following specific instructions. So here we are using, again, those XML tags to separate out those documents and instructions. This helps Gemini 1.5 Pro to disambiguate data from the instructions and process the prompt optimally. Also, notice the location of instruction and user input in the prompt here. So after the preamble, documents are added first, followed by instructions and the user input. So typically, you may have long documents that you may got from your retriever, and this placement actually helps the model to respond to the questions much better. All right, so this is again related to those rack-style prompts. You might have seen some of these charts before. So this is called needle in a haystack test, which is an evaluation technique where you challenge the LLM to find specific information which is hidden in a long context. So this helps to evaluate how well the model is navigating the different amounts of context to identify and use those crucial details within your prompt. So when running needle in the haystack test, the prompts that you're using matter a lot along with the tokenizer that you're using. So one of our partners was running a test with Gemini 1.0 Pro when it was launched, and they reported like 20% recall, which is pretty low. And we were actually working with the team, and we noticed that they were using the incorrect tokenizer as well as prompt template from a different LLM, and that was identified as the root cause for that lower recall. And after fixing both, we actually saw like 100% recall. And the takeaway here is the prompts do matter for these sort of tests. So there are a few ways where you can prime Gemini to get better responses. So one of them is asking Gemini to think out loud, basically to reason and add thought when providing the response. So this has shown to increase the amount of relevant details in the response that adds quality as well. And also asking Gemini to answer only when it finds relevant text. This can actually help you mitigate those hallucinations or verbose responses in a typical RAG or question and answering type of task. Then asking Gemini to read the sources or the inputs thoroughly before answering the questions. All right, summarizing prompt guidelines that might work for your use case. So simplify the instructions, keep them clear and specific, and limit preamble to 2 to 3 sentences, and keeping with the examples like 1 to 2 at most, and then starting with the temperature 0.5, and then either lower it or upper it based on your needs. And then avoid repeating instructions in the prompt, and for long context, you can add instructions towards end of the prompt along with the user input, and using the XML tags to structure your prompts, and finally experimenting with those trigger words or the priming words. So here we have a few case studies that we are helping our customers migrating to Gemini following some of those earlier tips I was sharing. So this is for that same multi-turn question answering chat that we saw. So after rewriting the prompts based on those guidelines, we saw that response from 1.0 Pro was found to be much more succinct and accurate than the other LLMs. And this is for another use case where we are migrating from text by send to Gemini Pro. As you can notice, the rewritten prompt is much simpler with instructions added towards the end. Another similar story, but for a different task. This was involving a query rewriting task where the original user query or the user input was rewritten based on the downstream system's requirement. So here we removed all those redundant and negative instructions that helped to improve the response quite a bit. So one thing which is common with all these case studies and tips is experimentation and evaluation, which is actually the key thing. Iterating those prompt variations or model versions, you can use some of those evaluation mechanisms to determine the baseline and then compare how exactly you are progressing with all these iterations. So ideally, you need some sort of an automated feedback engine that can report your metrics and also identify loss patterns along with the human feedback to verify those model responses. So Vertex AI evaluation provides those different tools to make this easier. So the service offers automated metrics to compute task-based metrics like blue or rouge scores, or even you can use the auto side-by-side pipelines to compare performance of the two models using an LLM without any reference data. Also this week, we just launched the Rapid Evaluation SDK for interactive and local execution of your evaluation on a smaller set of examples. Then you can actually go to the auto side-by-side or any of these pipeline-based metrics for batch use cases. And we had a talk on day 1. If you're not watched that, you can catch up on the recording from our Vertex AI evaluation team. But for a quick teaser, so the Vertex Rapid Eval SDK is the interactive Python SDK to assess each prediction individually. So it's integrated with Vertex AI experiments and allows you to define your custom evaluation criteria as well as, besides your pre-built evaluation metrics. And all it takes is like 4 steps. You define your, or prepare your evaluation data set and define the LLM that you want to run your evaluations against, and define the evaluation criteria with the metrics, and you can define the custom metrics as well, and finally run the evaluation. So you can see that the result of that evaluation run would be these summary and detailed results that are written as pandas data frame that you can use to, for any visualization that you see fit. All right, so you can find our prompt engineering best practices and prompt gallery by scanning these QR codes, but there is actually more than just how to talk to LLMs. Now, I'll actually invite Skander back to talk about those prompt design principles.
So, thanks, Rajesh. Now, many of you might have noticed that some of the prompting best practices and guidelines that Rajesh just presented sound a lot like what your social studies or English or history teacher was giving you, advice they were giving you to write proper essays in high school and college. Why? Well, there's a reason for that. See, Gemini is a next step in the evolution of LLMs, and it's coming a lot closer to how natural, like real natural language works. And if we look at the kind of first generation, not really first generation, there are several generations of large language models over the last few years, but the first wave, shall we say, of promptable large language models, they were not fully there yet. And so prompt engineering was really a bunch of hacks and workarounds to try to get them to behave more like natural, in a more natural language way, more so than some sort of like legitimate first principles based, discipline. And in a more technical sense, what prompt engineering was for the first wave of promptable LLMs was people accidentally discovering patterns that were in the pre-training or the instruction tuning data of the LLM, and then thinking that they have stumbled upon some sort of principle in how the dynamics of the large language model works, or how LLMs think, when it was just overfitting to the pre-training data. And so in order to kind of avoid kind of ground prompt engineering, we're not saying prompt engineering should be thrown away. No, it is a very, very useful practice, but in order to make it more robust and grounded, and to make it evolve as these natural language models evolve and become closer and closer to real natural language interactions, what we really need to do, and hence my reference to your high school and college teachers, is ground prompt engineering in the linguistics principles, not just how to hack into an LLM. And there is an already existing discipline called language engineering or linguistics, which the people who designed chatbots pre-generative AI, conversational design architects, the people who built search engines before there were deep learning-based embeddings, essentially, the language engineering is essentially the discipline of how to design systems where the user interface is natural language-based. And there are several decades of that we should be grounding prompt engineering in, versus just here's how to hack into the latest LLM of the week type approach. So let's look at what that looks like in practice. So look at how a conversational designer approaches the problem of designing a basic chatbot for ordering food. Now, there's nothing about new generative LLMs or prompt engineering here. This is just how somebody who was using, designing a dialogue flow-based agent for an ordering app sometime in 2019 would have gone about doing their job. So the customer request is, build us a chatbot for ordering food. Great. That's a very clear requirement from a business perspective. However, from a language perspective, ordering food is way too vague. So then, using linguistics principles, we'll use, there's a taxonomy of different types of food. That's what you'd call a menu. And then based on that taxonomy, the user journey, the path that the conversation is going to take will be different. So let's say that in this case, the business has either pasta or pizza. Then for pasta, the ordering process is relatively straightforward. It's going to be, what type of sauce do you want on your pasta, and that's it. For pizza, it's going to be a little bit more involved. There's going to be multiple ingredients, multiple toppings, and then once you get the toppings, there's going to be the crust, etc. So there's going to be two different flows based on the taxonomy of foods available. And using that, you're going to decide whether you want your agent to be multi-turn, so there's cycles in your graph, or not. Now, we want to extend this kind of approach, these conversational design principles and linguistics and taxonomy-based ideas, to modern generative LLMs, where we have the ability to prompt the LLM. And for that, we take the basics. So here we have a set of basic conversational design principles, and here we're showing how they get augmented. So for example, conversational flows in a standard dialogue flow, EX or ES or CX, now could get augmented by chain of thought reasoning and planning and execution type capabilities. Exception handling, now we can not do it just post facto, but we can also add guardrails in the prompt before the fact. So these are the list of how to think about conversational design principles as they are augmented to LLMs. But there's a much deeper kind of idea that I want you to take away from this. We're not just talking about dialogue flow and about conversational agents anymore. We're saying take the principles of conversational design and linguistics and apply them to all of your Gen AI solutions, even when they are not a conversational agent. So even if you're not building something using dialogue flow, even if you're just building your own, conversational design should become a set of design principles, a set of system design and architectural principles that you use to build any Gen AI solution. So what does that look like? Let's take this as a use case that our team has worked on, which is like document analysis, contract analysis. Now, this is a oversimplified version. I'm not saying this is how you would do procurement contract analysis. We're simplifying it just for the case of this talk. But let's say that you want to do procurement contract analysis, and your 3 asks from the customer are, we want to do compliance analysis, we want to do supplier risk estimates, and we want to do termination clause analysis. Now, how would you apply first, when we first started approaching this use case back in early 2023, the basic approach would have been to just treat it as a basic multi-turn RAG, what some people call talk to your docs, right? So just have a retrieval component and then a generative component, and the anti-pattern that we observed was that people would just try to have this really, really complex, highly verbose prompt that tried to solve for every single possible user journey in the contract analysis space. And that didn't work out too well. It would work maybe sometimes in a POC context. It would definitely never scale. You had to do a whole bunch of trade-offs. So you always had to use a very high-end, expensive LLM, even when it wasn't necessary for the user journey. You had to kind of figure out whether you're going to stick to a multi-turn LLM, but then shorter context, or a single-turn LLM, but really long context. So it was inefficient. Now, how would you apply conversational design principles to make this solution much more efficient, even though it's not a chatbot? OK, so let's take the request from the customer. We have analyze for overall compliance, analyze for supplier risk, and then extract termination clauses. Now, applying linguistic principles, analyze for overall compliance is too vague. Very likely, you want to break it up into a detailed analysis of the contract step by step, and then follow it by a summary of the analysis. Right? Now, both of these are likely going to be one-off, where you ask the LLM to do the analysis, and then human in the loop to review it, and that's it. Now, the next step for supplier risk is likely going to involve more multi-turn interaction, where you are talking back to the model and trying to say, well, but what about this supplier? And why did you say this supplier is risky, et cetera? So this part, you want to have a multi-turn back and forth interaction with the model. Now, the last part, termination clause analysis, is actually entity extraction, and you don't really need a high-end double-digit or triple-digit billion model to solve that. A smaller single-digit, even a BERT-level model might, well, maybe not a BERT-level model, but still, a small model would do this pretty well. So what would you end up with? You end up with a solution where you now have the detailed analysis part. You would use Gemini Pro 1.5. You might want to insert the entire compliance and risk manual into the context, and then let the model reason across the entire manual to do the detailed analysis. Then you'd use Text Unicorn, which is very good at summarization, to summarize. Now, you move over to the next step in the user journey. Now you want to have multi-turn, and it's going to be cheaper to use Gemini Pro 1.0 instead of Gemini 1.5 or Gemini or Text Unicorn, right? And also, you have the retriever now. You don't have to kind of go about coming up with one master retriever that can do overall compliance but can also do supplier risk. Now you have a retrieval which is geared to retrieving information about suppliers, fine-tuned to that task. Finally, for the last termination clause analysis part, Gemma allows you to do entity. You can fine-tune it to do single-task entity extraction. It's going to be smaller, it's going to be cheaper, and it's going to be very easy to fine-tune it specifically to your vocabulary, to your enterprise terminology and jargon. So, as we see here, instead of trying to have a free-form RAG solution where you're going to try to prompt engineer your way to a point where you can solve all of the user journeys on the fly, that's never going to work. It might work in a POC setting, but it will not scale. Instead, use conversational design principles to build a tailored solution to your specific use case. It will be better, it will scale, and it will be cheaper. And hopefully, like this kind of, like I said, this is not like just for chatbots and conversational agents. We're saying conversational design principles should be applied to a wider spectrum of use cases and seen as effectively like a starting point for how to do system design and architecture design for Gen AI solutions writ large. So, what are the key takeaways? First of all, to derive business value from Gen AI and from Gemini specifically, you need to move beyond the academic benchmarking mindset and into more of a business and product mindset. As we said earlier, there is no one LLM to rule them all. Make sure that you are choosing which flavor of Gemini or Palm for your use case based on your business and product requirements, not just on abstract benchmarks. Try to follow the prompt engineering best strategies, and we said they're as much about linguistics and communication, human communication principles, as they are about like some sort of engineering or hacking approach. Use these not just as how to prompt in context, but also as how to design the overall solution and system. And finally, there are limits to prompt engineering and prompt design. Whenever, like in the Gemma use case, a task-specific model that is fine-tuned in the Gemma example, sorry, a task-specific model that is fine-tuned to your corpus might just be the actual answer to your business use case.